Okay, today is October 12th. We're going to go over electron configuration, and this is for PreAP. All right, let's do a little bit of review of the atomic structure. Thomson, as we know, discovered the electrons, and he did that. His model was the plum pudding model. Okay, Bohr is the one who proposed the planetary model. This is the one you learned in middle school, which stated that the electrons orbited the nucleus, like planets orbit the sun. And this is where you learn the 2, 8, 18, 36, etc. energy levels. Then finally, the quantum mechanical model, or the wave model, which was discovered or written by Schrödinger, like the Bohr model, but electrons are located in energy levels. And he said there is no definite path. Okay. All right, so electron configuration. What we're doing here is we are going to look, where are these elements and electrons located on the periodic table. So there's some definitions that we need to know. The quantum, or quanta, you may say it with a UM or an A. The quantum is the amount of energy absorbed or released when an electron, moves to another energy level. We're going to do a lab where we look at the different colors given off, and that's the quanta of energy. The second definition is energy level. This is the distance of an electron is from the nucleus. A higher energy level equals more energy. Remember that there are 7 periods, meaning there are 7 energy levels. And remember, periods go across. You can think of it, we end a sentence with a period and it goes across. Atomic orbital. This is the region in space when an electron is likely to be found. Okay, the atomic orbital. Again, there's no definite path, so we say it's likely to be found. And we're going to learn in PreAP some sp hybridizations. We're going to learn a little bit more in depth about atomic orbitals. So then we have quantum numbers. These guys, you do need to know all 4 of the quantum numbers and what they mean. The quantum numbers describe an electron. It tells me where they are, like if I was giving you an address and directions to my house. The first quantum number tells me the energy level. And I know I can have 7. The second quantum number tells me the sublevel, the block. And what do I mean by that? We'll describe it here on the periodic table. The third quantum number describes the orientation of an electron in space. And then the fourth quantum number describes the spin. So on this generic periodic table, we're going to move helium here. So that way we don't have helium anymore. All right, so for purposes, we moved this helium over here. And the reason we did that is because we're going to show our energy levels here. And it's just easier and neater to see it there. All right, so then we have our S group, our S, our second quantum number. So remember, the 7 energy levels are our first quantum number, and then this is our S block, or S sublevel. Okay, then our next group is going to be here. Same energy levels, but this is our P block. So here are our P's. And remember, we've moved helium over. Let me color this. Okay. Then our transition metals here, Our transition metals are here, and they're a little bit bigger, you see, and so they're in the D. Okay, they're in the D, and they're a little bit bigger, so they lose energy, and we'll talk about that in a second. And lastly, the inner transition metals. This is the F block. Okay, so yours should look like mine. Different colors maybe, that's okay. But as far as the energy levels and the different sub-levels. Now again, this is, we have energy level 1 goes across, so this will be energy level 2, 3, 4, 5, and 6. Like I said before, D is a little bit bigger than P, so it's going to lose some energy, just like if we were at Thanksgiving after we ate. We're going to lose energy. So this is energy level 3, 4, 5, and 6. F is bigger, 14 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it actually loses 2 energy levels. And so this will be 4 and 5. Okay. So your periodic table should look like mine. Alright, so for every 2 electrons, we have 1 orbital. There is a maximum of 2 electrons in each orbital. So for energy level 1, which is my S, there is 1, 2. See, it says total electrons, count the boxes. So there are 2 electrons, so 2 divided by 2 is 1 orbital. And that's what we see here. Okay. Energy level 2, we have the S, energy level 2 goes to the S and to the P. So we have 2 sublevels. There are 2 electrons in S plus 1, 2, 3, 4, 5, 6 electrons in P for a total of 8 electrons divided by 2. So we're going to have 1 orbital in 1 orbital in S and 3 orbitals in P. Energy level 3, this one we need to be careful of. We have here, we have the S, we have the P, because I always like to go straight across the periodic table. We have the P, but this time we now have 10 in the D. Okay, so let's count the electrons. We have 2 in S plus 6 in P and 10 for a total of 18 electrons. See the pattern 2, 8, 18, just like you learned in middle school? So the number of orbitals will be 1 in S, 3 in P, and 10 divided by 2 is going to be 5 in D. Energy level 4. So we go across again. We're going to have S, P, D, and don't forget the F's down here. So we have S, P, D, and F. Total electrons, again, will be 2 plus the 6 from P plus the 10 from D plus the 14 in F. Let's start writing a 4 for a total of 36 electrons. Now, how many orbitals do we need? We're going to have 1 in S, 3 in P, because 6 divided by 2 is 3. D, we're going to have 10 divided by 2 is 5, and 14 divided by 2 is 7 orbitals for F. Okay, so I want you to practice this. Go ahead and pause the video. I'm going to continue. If the energy level is 3, how many total orbitals are present? So energy level 3, we have 1 plus 3 plus 4, so 1 plus 3 plus 5 is a total of 9 orbitals. If the energy level is 4, what is the maximum number of electrons possible? Like we said, 36 electrons. What is wrong with 2d3? Well, what's wrong with it is there is no second energy level here. So there is no second energy level in the D block. Okay, it starts with 3. What is wrong with 3s3? The S can only hold 2 electrons. Okay, so using a bigger periodic table, I want to go over electron configuration again. So again, this looks just like the periodic table from our notes, but this time it has elements. So we can look and see that hydrogen will be 1s1. Helium will be 1s2. There's no more elements on this row, so we're going to move down to energy level 2, always going straight across the periodic table. Lithium will be 2s1. Beryllium will be 2s2. Going straight across the periodic table, boron will be 2p1. Carbon will be 2p2. Nitrogen 2p3. Oxygen 2p4. Fluorine will be 2p5. And neon will be 2p6. Sodium will be 3s1. Magnesium 3s2. Going straight across the periodic table. Aluminum will be 3p1. Silicon 3p2. Phosphorus 3p3. Sulfur 3p4. Chlorine 3p5. Argon 3p6. Going straight across the periodic table, coming back down. Potassium is 4s1. Calcium is 4s2. Now scandium will drop down an energy level because D block is so big. Scandium 3d1. Titanium 3d2. Vanadium 3d3. Chromium 3d4. Manganese 3d5. Iron 3d6. Cobalt 3d7. Nickel 3d8. Copper 3d9. Zinc 3d10. Now we'll continue going across, so this goes back to energy level 4. Gallium will be 4p1, germanium 4p2, arsenic 4p3, selenium 4p4, bromine 4p5, and krypton 4p6. Now that's their location. So I want you to remember, just like if I was going to giving directions to my house, I wouldn't say, okay, you're going to pass the big house, the small house, the house with the tall windows, etc. So we don't have to write all of those numbers in. What we can do then is we can just say what's at the end of the block. So if I was going to tell you lithium, so let's write lithium. Lithium is 1s2 because we always have to start at the beginning. And then going down to energy level 2 is 2s1. Beryllium is 1s2, 2s1, 2. You see it has 4 valence electrons. 2 plus 2 is 4. That's how we can check ourselves. Now let's look at boron. Boron will be, starting here, 1s2, going down, 2s2, going across, 2p1. Carbon, 1s2, because we always start at the top, 2s2, then 2p1, 2. And it says it has 6 valence electrons, or I'm sorry, 6 total electrons, and so there are 6 electrons. It has 4 valence electrons, and that second energy level is our outer energy level, so 2 plus 2 is 4. Alright, let's do nitrogen, and then we'll continue our notes. Nitrogen, starting at the beginning, is 1s2, 2s2, 2p1, 2, 3. And so forth. And then until we continue. Now, if I wanted to do titanium, I would have to say 1s2, 2s2, 2p6, because we're going straight across the periodic table, 3s2, keep on going, 3p6, because there's 6 valence electrons, coming down to 4s2, and then titanium 3d12. Okay, so that would be titanium. Thank goodness we don't have to write too many of those, but we do have to write some. Now, the rules for electron configuration, you must memorize, must know. We have the Aufbau principle. This is a German word that means to build. And the start from the bottom and go up, the totem pole. Aufbau means, like I said, to build. Electrons are going to enter the orbitals in the lowest energy level first. That's why we have to say 1s2 first, because it's going to enter the lowest energy level. Now, Hund's rule, also known as the empty bus seat rule, there's going to be one electron in each orbital, in each sublevel before you go back and pair. Then the Pauli exclusion principle says there's a maximum of 2 electrons in any one orbital. Okay, so there's 2 ways to represent electron configurations. The one I showed you earlier was called the longhand configuration. And we're always going to start with 1s and fill up energy levels going straight across that periodic table. Energy levels and the sublevels until you get the electron or the element that you want. The shorthand configuration is so much nicer to write. We're going to put the noble gas that comes before, very important, the element from the previous row in brackets. Then finish the electron configuration there. So let's look at that. So here was our practice. So now instead of lithium being 1s2, 2s1, we go up 1 energy level over to our noble gas. So that will be helium. So now it's going to be helium. Oh my goodness gracious, I put the bracket in the wrong way. It's going to be helium, so sorry about that, 2s1. Beryllium, again, we're going to go up 1 energy level, will be helium 2s2. Okay? Boron, again, going up 1 energy level to our previous noble gas, will be helium 2s2, 2p1. Okay? Carbon, going up 1 energy level to our noble gas, will be helium. And then everything that's left over, 2s2, 2p2. Now let's look at titanium. So titanium is here. Go up 1 energy level to the previous noble gas, and that is going to be argon. So we're going to have argon in brackets, and then this is our last part, 4s2. We're going to put argon in brackets, 4s2, and then 3d2. Right? So go ahead and practice your configuration. So looking at uranium. Uranium is all the way here to 5F1, 2, 3, 4. So we have to list everything that's before it. So 1s2, coming down the periodic table, 2s2, going straight across, 2p6, coming down the periodic table, 3s2, going straight across, 3p6, coming down the periodic table to energy level 4, 4s2, going straight across, 3d10, straight across, 4p6, coming down, 5, I'm going to come down here, 5s2, 4D10, 5P6, coming down here. Now be careful, this is where these guys insert. So we're going to now be at 6S2, 5D10, oh, I'm so sorry, 4F14, because 4F comes in right here. So we got to make sure that we put that there. Okay, then 5D10, and then we're going to keep on going across the periodic table to 6P6, coming down to 7S2, 5F1, 2, 3, 4. Thank goodness we don't have to write it like that all the time. We can do this shorthand configuration. So we're right here, so we're going to go one noble gas before, which is radon. So we can put radon in brackets and then finish with 7S2, 5F14. So how many valence electrons are in here? These are, remember, energy level 5, so these are not valence electrons. This is going to be 2 valence electrons from this S block right here. Then how many valence electrons? Look at the highest energy level and count up. We'll just write that. So we're going to have 2. All right, so then I want you to try boron, sulfur, and iron, and we'll go over it in class.